Hello everyone, I am Payal. I'm a second year electrical student. Today I am going to discuss Manacher'S algorithm, also known as longest palindromic algorithm. If someone doesn't know what is a palindrome is a sequence of letters that is same when written in reverse order. For example, peep, madam, label, pop, radar. If you reverse the is word, nothing will change. Pip will remain pip. Or in other words, we can say that the half right part is the mirror image of the left half part. Here we can see this looks like a mirror image of this. Here it looks like a mirror is placed in this, and this is the mirror image of left part. Okay. Similarly for madam label. In case of odd length palindrome, middle character considered as a mirror or looks like a mirror and right part is the mirror image of the left part. In other words, we can say that. And now the question comes, what is the purpose of Manacher's algorithm? So Manacher's algorithm is used to find the longest palindromic substring in a given string. For example, in first string, the longest palindromic substring is of length 5. Here another palindromic substring is also present of length 3, but we need maximum, therefore we consider this part. In second string, in maximum length of longest palindrome is of 6. Here 6. And two more palindromic substring is also present of length 2 or 4. Here FF or GF. Now the question arises in our mind, is the Manacher's algorithm is the only way to solve this problem? So the answer is no, there are many ways to solve this problem, but why we use Manacher's algorithm to solve this problem we discuss in further slide. Let's first discuss one or few approaches to solve this problem. First approach is brute force approach or naive approach, where we first find all possible substrings of a given string using nested loops, which takes O of n square times, where n is the length of a given string. And then for every substring we check if either it is a palindrome or not, or which takes O of n times. So the total time complexity is O of n cube, which is not good at all. Another approach to solve this problem by using dynamic programming, which takes O of n square times and requires O of n square extra space to solve this problem. In DP, we simply store the results in a matrix of size n plus 1 cross n plus 1 cross, where n is the length of a string, so that we don't need to calculate it again and again. And again, the solution takes O of n square times which is not more good, which are not so good. This solution can be further optimized by the idea is to fix each character of a string as a center and expand in both directions for longer palindrome and keep the track of the longest palindrome. Since so far its solution takes O of n square times with O of n extra space. Basically, this is a slow algorithm where we fixing each character as a center and expand in both directions for her keep tracking the length of a longest palindrome seen so far. Again, the solution takes O of n square times, which is not so good. Now the question comes in our mind, can we do better? So the answer is yes. We can solve this problem by using Manacher's algorithm, which takes O of n time and O of n space to solve this problem. Let's start our discussion on Manacher's algorithm. Manacher's algorithm is used to find the longest palindromic substring in any given string. This algorithm is faster than brute force or DP approach, as it exploits the idea of a palindrome happening inside another palindrome. What does this mean? It exploits the idea of a palindrome happening inside another palindrome is, let's consider an example. We have a string of length 11 and we find the maximum length of a palindromic substring is of 7. Then all the subpalindromic substrings which occurring inside the longer palindrome, we don't need to calculate all these values. By using some property, we just copy paste some value. This property I will discuss in further slide. And And the second point, initially Manacher'sAlgorithm algorithm is used to design to find in palindromic substrings with odd length only. That means initially this algorithm is useful for the string which have odd length, but to use for it even length, we insert some special character at the beginning and end and between spaces of two characters so that it can be used for even length also. In given string, we first convert the string by using special character or any character. You can use any character. Here I am using as character. So the longest palindrome is of odd, because after removing hash we get a palindrome of length 3 and the middle character is the string character. But in case of even length palindrome, middle character is the hash character. Let's take an example to understand this algorithm. Let's consider a string as this. First we need to convert this string by inserting some special character. Here I am using as character. Here blue value indicates indexing, and then create a array or a list of size 2 and plus 1 where n is the length of a string. Here this value indicates the half length of a palindrome. For example, if we consider this as a center of a palindrome, so it cannot further expand in either left or right. So the maximum length of a palindrome across, if you consider this as a center, is 1 and their half value is 0. Integer, we considering integer part. And if you consider a as a center, then it expands left up to 1 and right up to 1. So the maximum length of a palindrome is 3 and half of the value is 1. We consider only integer value. Similarly, we calculate for each character and we observe that the maximum length of a palindrome is occurring when we consider b as a index, when we consider index 7. And one other observation is that all the right value, it looks like a mirror image of the left value. And this property is the most important property to solve this algorithm, to solve this problem. Now the question comes, when we apply this mirror property, is the mirror property apply in all cases? So no, mirror property cannot be applied in all cases. Mirror property is applied only when this condition will fulfill. When the difference between this r minus I, where r is the right limit, how much it expand up to, if we consider its index 7 as a center, then how much it expand and right. So right limit, if this value is larger than or greater than equal or to p of I value for this. Here observation 1 is written. For the center or index c equals to 7, p of c equals to 7, and which has the longest palindromic substring. Notice that the number in array p after center c are same as the number before center c, so avoiding expanding around all letters after center c. However, just put their values directly using mirror property, so we don't need to calculate it. Another observation that we cannot apply this mirror property in all cases. In some cases mirror property is not applicable. Let's understand when this property is not applicable. Let's consider a string this. After converting this string, the new string becomes this. For this string, we calculate the p array which stores the half length of a palindrome if we consider each character as a center. Here we calculate all this value, but for if we observe for index I, the mirror image will be index 9. But these two values are not same, because the second palindrome of length because the second palindrome at index 9 goes beyond the limit of the first palindrome. In that case, we update our center I. Initially our center at index 5, if we update our index to 9, that is new center is this, and the right limit is also changed. So how we find the right limit? The right limit is basically the index of this and how much it expands up to right. So the value at this index value. Same thing I did in this. The mirror property does not work in all cases because in this case there is another palindrome with center c equals to 9. In this new palindrome with center c equals to 9 goes beyond the limit of the first palindrome with center c equals to 5. Here looks the steps of this algorithm. First we declare two limits. It's a left and a right limit and a center. Or initially we a right limit. How we, so as we know, if we consider, suppose we indicate the C as a center of a palindrome, so I dash is the mirror image of I. If we consider I index left side of the center, then I dash will be the mirror image, and the center and the distance from the center of this will be both are same, both were same. So the mirror property is applicable when this is true. If it is not true, then we update our center, or our center c equals to I dash and right limit. This means that the palindrome with center I dash goes beyond the original palindrome, so expanding around the center I dash is needed. Here basically how much it expands up to right. R minus I is basically indicated, and if we consider C as a center, or if we consider, so expanding around center I dash will start from this. This algorithm has two nested loops. Outer loop check if there will be an expanding around current later or not. This loop takes n steps. Inner loop will be used in case of expanding around a later, but if it is a guarantee that it takes at most n steps by using 2 observations. So the total time is 2 times n, which is big of O(n). So when we update the center, when the second palindrome goes beyond the limit of first palindromes. Here, when a palindrome with center I dash goes beyond the original palindrome, then we update the center. A new center become I dash, and the right limit becomes the index I dash plus the value at this index. That is the code for this algorithm. Here we got, first we convert, here a string is passed. Here first we convert this string into a new string. Here the code for converting the new string is written there, and we then first we initialize the center and the right limit to 0, and then iterate over each character for this string q. And first we calculate the mirror image for each index I. If for index I the mirror image will be calculated by this. You can understand how it calculated, and applying, if I is less than right limit, then we simply takes the minimum value of R minus I and the value at P of I. I mirror is basically the mirror image of I. Expanding around I occurs if suppose we consider I as an index and expanding in both sides till both are equal, and updating when the second palindrome goes beyond the limit of the first palindrome, and then we check the maximum value and see out. So conclusion, time complexity of this algorithm is O of n, and space complexity of this algorithm is O of n. Thank you from my side.